Hello, everybody. We are here with Thomas Kidd. The subject is New Ideas in Spectrum, and we have the right man for the job. Thomas specializes in strategic, military, federal, national, international electromagnetic spectrum policy, strategic management, and politics. He's led an initiative that reduces the cycle time for commercial broadband siting process in the Department of the Navy, installations for approximately 5 years to less than one. So that's a big reduction. And I'm sure that wasn't easy operating inside an organization as large as the Navy. He's advised the White House on how the department's streamlined process for commercial broadband deployment policy could be implemented across the federal, the whole federal horizon. So we're very pleased. And Thomas has got a series. I got a little preview with him the other day. He's got a series of really interesting items. I think any spectrum manager, anyone both on the federal and on the industry side, would be interested in. So take it away, Thomas, and welcome. We're so pleased to have you.
Thanks, Joe. So in the past, when I've spoken to NSMA, I've usually talked about the internal initiatives that we have going on within the Department of the Navy. And then I end that presentation with some of the things that we have in the queue, some interesting, strange, unusual things that we've been working on. And those always seem to be the topics that we end up talking about. So although we do have some great initiatives going on within the Department of the Navy, new policies, et cetera, like that we're working on, for this engagement, I thought I would just start at the end. And I would mention a few of the things, 4 things actually. Joe and I talked about 3 of them, but 4 things that we're engaged in right now, or that we have going on, some initiatives working in the background, trying to kind of change the landscape a little bit within the spectrum community. The 4 things, excuse me, that I want to talk about are going to be artificial intelligence, but probably not the way you think. Wireless power, and we're talking about power beaming, long-range wireless power, not the current discussion going on at the ITU. Obstructions, and with obstructions, I don't mean FCC, NTIA, et cetera, towards spectrum. What I mean by that is actual physical obstructions to electromagnetic spectrum, and maybe should we be thinking about this? And then a little bit about the National Radio Dynamic Zone and this new concept that's being worked right now, mainly out of National Science Foundation and the great work they're doing there. So those are the 4 things we're going to talk about. They're not really related to each other, so at any time, jump in to ask a question, and I will try and keep myself on time. So artificial intelligence. AI, machine learning, et cetera, right now are some of the big buzzwords that go around. And it's often discussed to solve really challenging problems that may be outside of the realm of what human beings can easily solve. I've been pushing an effort to try to use AI in the other end of that spectrum. Many of us who have grown up in the spectrum community and the spectrum management community, we know that there are some huge challenges that need to be solved within the world of spectrum management. Mitchell just talked about several of them that went on, and the politics that get involved in solving these problems. The challenge that I'm finding is that many people in the spectrum community, and a lot of the folks that are in the Department of the Navy spectrum community, they relish working on those problems, but they spend 90% of their day in mundane, boring, filling out digital paperwork, transferring data from one page to another, just so that they can file to get their frequency assignment or license from the federal government. And this is mind-numbing activity. It's unique enough that it can't be easily automated. NTIA has just started a new initiative to try to automate much of the spectrum management process, and I wish them all the best in doing that. But a lot of this type of work is just unique enough that it would fall into the realm where it would require maybe some machine learning or some artificial intelligence to actually be able to solve it. But my goal here would be that every spectrum manager would have the ability to have an AI assistant, somebody that you can shuffle the boring basic paperwork, this day-to-day stuff off to. Now, this may seem like, you know, a waste of AI, and I've got to be honest, it is one of the challenges that I'm running up against because it's not really flashy and glorious. You know, I'm basically talking about, you know, hiring, like I said, an AI assistant. But the advantage, if we can get this done, is that this AI assistant can talk to all the other AI assistants. And so when somebody is trying, we all have had this experience where we use our last experience in our filings with FCC or NTIA to influence our current filings that we're doing, our current paperwork and stuff that we're doing, but things have changed slightly. It would be really nice if, as our assistant was working this through, they had the opportunity to talk to every other assistant so they could tell me, hey, Tom, you know, when Jane just filed this paperwork 3 days ago, the result actually was they wanted this particular information in this format. Is it okay if I switch it to that format? Because it'll make things quicker. And spectrum management right now, and probably into the near future, even with all the automation, is still going to be very much people-centric. It's going to be a very manual process. It's still going to involve talking with people, whether on the federal side of the government, it's at the frequency assignment subcommittee, or it's the federal agencies talking to each other, or as Mitchell in the previous briefing mentioned, you know, having our meetings and trying to work out our differences, etc. A lot of this paperwork and a lot of these things that are going on in the background, I just think that if we were to be able to bring artificial intelligence, machine learning, robotic process automation, these slightly more than normal automation, more than moving digital paper around, if we could bring them into the process, that it would definitely make our spectrum managers' lives easier. I jokingly tell the folks in the Department of the Navy spectrum workforce that I'm continually trying to replace them with robots. The reality is that we never will. The goal here is, rather than taking things, if you were to take all the work that you've got to do in your life today, in your spectrum management life today, and put it in a stack of the hardest stuff is on the top. That's the stuff you want to work on. And the easiest stuff is on the bottom. My goal is that artificial intelligence will pull from the bottom of the list. It'll just be taking care of all of the easy, stupid stuff in the background, freeing you up to do the stuff that humans do best, which is argue with each other over these political reasons that we're having to do things because we just can't agree on what the studies obviously show. So that's my pitch towards this level of artificial intelligence. And the reason I'm pitching it to you guys is I'm trying to get a bit of a grassroots going. I've probably submitted 6 proposals within the DoD, within the military system, to do this. And any AI project is expensive. They always, the underlying cost, the startup cost is usually pretty high. So consequently, people want to solve these big problems. And getting the funding to solve this apparently mundane problem that could just be solved by hiring more people isn't always seen as the flashiest thing to use AI for. Unfortunately, we can't always just hire new people. And if you hire new people, then you spend 5 years training one person, where if you can hire AI, you spend 5 years training the AI, and it is automatically trained across the universe. So there's great benefits to this style of AI. Hopefully, if you're in a place when this type of conversation comes up, when somebody's talking about solving the traveling salesman problem, or a multi system situation, and they're talking about using AI and machine learning, you can drop in there, hey, I heard this other application of AI that I think would be really beneficial. So that's my pitch on that. And I'm going to pause here just for a minute, see if anybody has any questions about that. I don't know exactly how the questioning works. There we go. Hey, Joe.
Hey, thanks for that. On the AI assistants, when it comes to spectrum managers, one question that popped in was, often spectrum managers obviously have different degrees of confidentiality. You know, one big mobile company might not really want to share with another big mobile company who's their competitor,
right?
Certain things. So a lot of this is done in different gradients. How do you anticipate that working in this new regimen?
Right. So the way that we were earlier explaining this, of replacing the workforce with robots, it would work very similarly. And in fact, the idea would be that we would almost have the equivalent of little Turing machines here, so that you could call the robot Jane, or the robot could be Bill, or whatever, you know, the AI. And that particular AI has access to the same information your assistant would have, and the same restrictions on sharing that information that your assistant would have. And in fact, it would probably be better with AI, because your assistant might try to talk around something, they might inadvertently say something. The AI wouldn't. It would be strictly bound by, you know, by the three laws of robotics. No, it would be strictly bound by whatever its programming was. The advantage, of course, would be that if you're in a fairly large company, or an organization like the Department of the Navy, where we have thousands of spectrum managers, is that where it's appropriate, we also do have, of course, compartmentalized information and things like that, and times where we wouldn't necessarily want to share information even within the Department of the Navy. But in those situations where you can share the information, one of the great things that I see on this is that instantaneous across the board learning. If a rule changes at the FCC, and it has to do with any of these tasks, these mundane tasks, instantaneously, every single assistant across the spectrum community knows the rule has changed, and therefore will advise their employer, whoever it is, next time they're being asked to do something, are you sure you want me to do it that way? It doesn't necessarily inhibit innovation either. In some of the conversations we've had with some of the visionaries in these areas, you can actually tell the AI to do things differently. You can say, well, okay, but I'd prefer to do it this way because, and they'll do it that way. And then if that's more successful than the way the other AIs are doing it, that information gets shared as well. So it is very much a personal interaction with the machine. And in fact, the way that I hired the Center for Naval Analysis to do a study on my workforce, and one of the questions I asked them to ask was how does the workforce think would be the best way to interact with this kind of AI? And overwhelmingly, the answer I got back was very similar to the way we interact with each other today. Although you and I and your audience were talking with each other, that's not the way we interact on a day-to-day basis. We interact mostly through text, mostly through email. And AI is especially well suited for that. So instead, so you just receive an email from Jane from the Department of the Navy to coordinate on a microwave link in Southern California. You have no idea that Jane is actually an AI assistant working for me. Jane asks you plain text questions. You answer in plain text. If clarification is necessary, conversation ensues. We see these kinds of chatbots working today in different situations, and they're absolutely fascinating. So that kind of thing could go on. In the same way with information, and because of the way these programs work, if you had a certain kind of information you didn't want released, the AI could infer from that, you know, semantically infer from different conversations that are going on, and potentially even say, well, hang on, Joe, I got to get back with Tom and ask whether or not I can give you that information. Because it might, you know, there could be these fuzzy areas in the middle where your assistant would say, hey, Joe seems like a good guy, so sure, I'll tell him. Yeah, you know, and stuff leaks out. So that's kind of the way that I would see that working. Hopefully that answered the question.
It did. It's very intriguing, and I, you know, just speaking from how it first landed on me, and literally in like 1987, 88, I was filling out FCC broadcast contour application forms, and all that rote stuff. Which never left some realm of my my world. So I think a lot of us intuitively get that could be a total load off, and your concept of taking off the bottom of the pile I think has a lot of intuitive sense. And you're talking to a lot of spectrum managers and coordinators here. So I think and you got some thumbs up came up, and you also got I guess a high five from Joseph. He's saying, my man, and you're getting a few more high fives. So people are listening. No, 8 more high fives. There you go. All right. Well, good. Right. Well, I know you got more to say. So
next topic. Let's move on to the next topic. All right. So this is power beaming, or long range wireless power, as it's sometimes called. This is not putting your cell phone on a wireless charger. This isn't really even in-house type stuff that can be done in unlicensed spectrum. The most dramatic, spectacular, but probably least likely application of this, at least in the near future, is space-based solar production, and then having to beam megawatts of power down to the Earth. The more likely application is going to be relaying, possibly from the ground to space and then space to Earth. And also, we've had some interesting conversations with the fossil fuel industry. And for example, natural gas pockets tend to be very small, and a natural gas power plant isn't much bigger than a large house. At least so I'm told. I haven't actually been out to tour one. But the challenge, of course, is you either then have to pipe the gas to the plant, or you have to put up wires to get the power from. If you put the power plant at the gas field, which they are relatively transportable, I'm told they can actually move them from these small natural gas deposits one to the next, but you have to build distribution lines and stuff like that then to get the power. So if you could, for example, beam that power back to, use relays or whatever to beam it back. And although, one of the first things we think about is efficiencies in systems like this, the efficiency, although of course it's important, any kind of an efficiency when you're moving any commodity is important. It really does come down to cost per kilowatt hour. If it can be done at a profitable cost per kilowatt hour, efficiency doesn't matter. You can lose 75% of the power or more. It doesn't really matter as long as you can still make money at it. And there are some parts of the world and some locations where that's practical. So what's the problem? One problem is technology. This technology isn't going to probably mature until somewhere around mid-century. There's still a lot of people working on it, but it's still, we all know that in transmitting information, it's not necessarily the amount of power that gets there, it's the quality of the intelligence on the signal. You can lose 99.999999% of the power in a transmission as long as you can recreate the signal, recreate the intelligence. Power beaming is completely opposite. Realistically, with the exception of probably some embedded control signals or whatever, the power is the commodity. It is the thing being sent. So you need efficient methods. And so they use rectennas instead of antennas. Some of this technology is really unique in how it transfers the energy. All right, so what's the problem? Well, currently, within the spectrum regulatory scheme, power itself is not a type of service. We have radar, we have radio location, radar, radio location, we have radio astronomy, we have fixed and mobile telecommunication services, but power itself isn't technically a telecommunication service. And it's unlikely that power is going to be able to the unlicensed spectrum. It's going to have to exceed the out-of-band emissions or even in-band emissions, things like that. We're not sure. There's still an awful lot of research going on what frequency bands to use, and what the signal will look like, what the waveforms will look like, and things like that. But none of this can go to full fruition if it's going to operate in the electromagnetic, in the radio frequency spectrum. Some of this stuff operates in the laser spectrum, and at least currently, it's not necessarily a problem, or we're all radio frequency spectrum managers here, so maybe that's someone else's problem. But for us, there are going to be instances where the best way to transfer energy, to transfer power, is going to be in the radio frequency spectrum. And much like some of the things that we've heard talked about before, if there's not an existing regulatory construct to handle power, it could very easily just be a dead technology because there's just nowhere for it to go. There's currently nowhere in the radio frequency spectrum to transmit megawatts, let's say, or even kilowatts of electrical energy point to point on the ground or earth to space, space to earth. There is no such thing as a type of service for power. Now, the answer to this may not be getting the ITU to create a new type of service for power. The answer might be to get power recognized as an application within fixed and mobile with special rules that are against it, that work for it. So we're not exactly sure. We have a small group that we put together a few years ago when it became apparent to some of us that this was likely to occur sometime again. Like I say, the futurists are predicting that this will become probably a viable technology somewhere around 2050. But if any of you have worked with the ITU before, you know that if we're going to, let's take worst case scenario, and this is a type of service, a new type of service, and we're going to have to allocate spectrum, or excuse me, reallocate spectrum from an existing type of service to this new type of service. Let's just assume that it's not compatible with incumbent services. The running joke was kind of a scorched earth thought. You know, you have a big beam of energy coming towards the earth. It's not that dramatic. Everything that I've seen on it, the beam can be spread out over a fairly large area, so the power density isn't high enough to cause harm. But nevertheless, in the electromagnetic spectrum, it may be a very, very noisy signal that's coming down. So let's assume for a moment, worst case scenario, that 2 or 3 narrow frequency bands are allocated for power beaming or long range wireless power. There are incumbents in those bands. Those incumbents, spectrum on a global scale has been reallocated before when there is a global need for it. And so those incumbents would then be asked to move. On a global scale, moving out of a band, that's a 10, 15, 20-year proposition, which now moves us back from, let's say, 2050 to 2030, when that decision has to be made. And this is a dramatic move. Okay, so it's not going to get done in one cycle of the World Radio Conference. It might take 2 or 3 cycles. It may take a lot of studying. Well, 2 or 3 cycles is potentially 12 years, maybe even longer. So that now backs us back from 2030 to 2024. It's 2021 right now. We got Work 23 coming up. Does this kind, if we're going to require massive change or change to global spectrum allocation, do we need to engage now? You know, do we need to start this conversation at the ITU? The answer to that question is yes, we do. And so one of the member of our small team is my international lead, Fumi Wingo. Another member of our team is Paul Jaffe from, he's well known in the power beaming community. He's at the Naval Research Lab. So, so that's kind of where we're thinking on this. And one of the questions I often get asked is, why Navy? Why were we so urgent on thinking of this? There's several reasons. I mean, one, we just kind of have a history of looking at different innovative ideas, along with the other military services and other federal labs. We all kind of have our own different things that we look at. So there's maybe a little bit of culture, but also the Department of the Navy spends a lot of effort, money, blood, and treasure transporting fuel so that we can create electricity. And our ships are electric. Much of our future is electric. If we could get electricity from point A to point B without having to transport the fuel to get it there, if we could beam energy from point A to point B, even if it's like a bent pipe type satellite or some kind of giant reflector, I don't know. I watched the briefing earlier today on space debris. I think if the Department of the Navy wanted to put up a kilometer-sized mirror up in space, we might get a little bit of pushback on that. But nevertheless, you know, the Department of the Navy spends a lot of money, a lot of effort trying to create electricity at far-flung locations. And so it just seemed logical that we would get involved in this. There are other countries that are involved in this. We've talked with the folks in Japan. Japan is very interested in this kind of technology, and they've been doing some incredible work on power beaming. So we've had some good conversations with them as well. So we are introducing this concept at the ITU. We're working through. There is currently an agenda item on, we'll call it medium range power beaming, and so we're exploiting that. We're also exploiting some of the work that's been done by Japan, etc. So we are we're working on this. Probably the one other thing that why I think this is such a great initiative. So I understand the controversy of Starlink and similar type devices that, similar type constellations and everything. However, if we flip it around just for a second, forget about the method of delivery and just think about what it's going to mean to global society to have high-speed internet access everywhere. Everywhere on the planet, you will have high-speed internet access. Regardless of where you live, vacation, doesn't matter. You're camping in the middle of the woods in the Rocky Mountains, and you will have full-up communication. The safety reasons there, everything, all the kind of communications, the social implications of all of that are huge. For civilization to basically exist, you need food, you need water, and you need energy. Historically, that energy has come from chopping down trees or burning fossil fuel. If you have a nearly unlimited access to electricity, you can live, human beings can live in a lot of places where we can't currently live. So this could actually open up some portions of the world to settlement, to new settlement. It could also increase the ability for various parts of the world to progress technologically, because currently terrestrial delivery of power or delivery of diesel fuel for generators to create power is a big challenge. I mean, there are a lot of social aspects to this to also be considered, but none of that is going to happen if the rigid regulatory system that we currently have in place is forbidding of it. If there's no place for it to go, then it just simply won't happen. So I spent a little long time talking about that, but it is something that's that I'm very passionate about. So open the floor up if anybody has any questions or anything about power beaming or long-range wireless power.
Yeah, thank you for that. That is very interesting. One of the obvious questions that popped up was, and maybe this is already in your mid-range power beaming item, is, I don't know what the noise is coming from somewhere. Is that from you?
Yeah, it's on. Okay. Yeah, I share an office.
Oh, okay. Sorry. So the mid-range power beaming, if that is defined in traditional, let's say, fixed wireless analysis, where you're trying to see if network A is going to interfere with network B. Right. There's a ITU has very specific processes for filling in. So do you have the characteristics already, or the proposed characteristics for a mid-range power?
So the mid-range, and I don't think that's the official term right now. It's the stuff that is currently at the ITU being worked on right now. And this is like in building, in-house, the idea of being able to charge your cell phone from a transmitter on the wall, things like that. And I don't know the specifics off the top of my head, but we're trying to distinguish what we're doing from that. We're talking kilometers, tens of kilometers is the type of things we're talking about, not wireless transfer of power like over a very short distance that could be done, let's say, inside a building, and even at frequencies potentially that then you can use the shielding of the building. The stuff that we're talking about is I think there's currently a test pending that's going to try to transmit a fairly large amount of power, like 10 kilometers. Okay. So that's the kind of thing and there are no specifications right now on that. That's actually a discussion that needs to happen on what those would be, on how wide the bandwidth will eventually need to be, out of band emission requirements, in band emission the whole 9 yards. I mean, right now, kind of a funny story when somebody who has participated, this is a kind of an ad hoc little group. It's not an official group. We get together periodically and discuss amongst ourselves. It's kind of a coffee klatch way of doing things. And one of our members happened to be talking to somebody at the ITU and talked about this a little bit, and was told, well, power is not a telecommunication service, so the ITU wouldn't regulate it. To which our colleague spoke up and said, so that means we can use any spectrum we want, right? And you can't hold us accountable for interference. And the answer was, well, no, not exactly. But I mean, along those lines, we've talked about starting this conversation with ISO, you know, or possibly somebody else who's one of the ITU contemporaries, and then that contemporary can then bring it to the ITU.
Yeah,
for guidance.
Well, let me ask a few questions that have piled
Sure.
in, and if your colleague in your office is still talking, if you go on mute, at least you'll be able to hear.
Sure, let me do that.
Some of our people can't hear. Okay, you ready? So we have two sets of questions. One's from Harvey List, National Radio Astronomy Observatory, and Harvey's noting that there's a lot of significant power levels with wireless transfer of power, obviously large amounts of power. For instance, how solar power satellites are lethal and sunlight falls on the Earth already, and we need to take better advantage of that. And he has some questions along that line. He also is stating that when you transfer such large amounts of power, the unwanted transmissions are strong, harmonics, and I guess OBE as well is what he's talking about. So that goes back to my question. He said he couldn't hear my original question, which is if you have some spec sheets or some prospective, although the equipment's not already here, if there's a way to build spec sheets around this, then we can all start grappling with what this looks like. Is this 7 blind men and an elephant, or is this 2 blind men and an elephant? Then we have a little more different way to understand it. So that's question one. And then there's a question from Thomas Willis, who's on our board from AT&T Labs, which is how big are the collectors for these systems? So those are the two questions.
So I'll go with the second one first, and it falls into Department of Energy, I think, came up with this analogy or whatever. They nicknamed it. It was nicknamed the naked skydiver analogy, which was basically the beam has to be safe enough if it's coming from space to Earth, so that if someone jumped out of an airplane in the middle of the beam, completely unprotected, and came all the way to Earth, that level of duration, et cetera, wouldn't be harmful. That's not scientific. They were just making a point. And I've heard that space to Earth collectors, at least the array on the ground would be kilometers across. It wouldn't be a small dish. It would be a very large array. Back to the other question, to talk about these kinds of parameters and things like this in like an international forum at the ITU or whatever, you need to have a vocabulary to be able to talk about it, and you need to also have a recognition by that body that this is something they want to talk about. So that's the step that we are right now. I know that there are some papers out there. Is it Dr. Shinohara? Is that who it was from Japan? I think has submitted some papers on some of the characteristics, and there are a lot of companies out there that have published some information on power beaming. The challenge that I'm trying to tackle isn't the technological one; it's the political regulatory one. It's the where do we talk about this? Who do we talk about it with? And so that we can actually get it across the finish line. And if it's going to, I'm perfectly okay if this dies for legitimate reasons. There's plenty of ideas that have come out. One of my favorites was one of the reasons that within the Department of the Navy we have such a strict equipment certification process is because we have a lot of brilliant engineers and scientists out there that develop new systems, except it would devastate the cell phone industry or whatever. And so it's dead on arrival because, sorry, if it's got to operate in that band and it's going to wipe out every cell phone, within radio line of sight, then you're never going to be able to produce that device. And if this is one of those, that's fine. It would just be a shame if this isn't. If this is something that could be done from a technological perspective, but can't ever get done because of a regulatory and perspective.
Well, thanks for sharing that. I think that answered those sets of questions, and I I think we still have some time for
We
your
still
other.
have about 8 minutes.
Yeah. What else you
6
got
minutes.
on the idea list?
So I added one to the list from what you and I have talked about because we're currently having our Navy Marine Corps Spectrum Summit this week as well. And one of the topics that I talked about there that got an awful lot of feedback and I wanted to bring up here has to do with obstructions. And these are physical obstructions to RF. We, within the Department of the Navy, often have challenges with windmills. We have challenges with other things. But as we move into higher and higher spectrum and line of sight becomes absolutely critical, and as we densify, we have what we call encroachment, where people are building closer to our fence lines, or even potentially putting structures physically on our base for various reasons. We're trying to crack this nut of protecting the beam. We protect RF from other RF, but the actual path itself is not really protected. If somebody puts up a point-to-point microwave that goes 15, 20 kilometers, but 2 blocks away somebody builds a 15-story building and blocks that beam, the RF person, the communications person really doesn't have, I mean, they can work with them, they can try and be a good neighbor, they can do whatever, but they don't have any real rights right now. They can't, there's no requirement, generally speaking, there's no requirement in the permitting process of where somebody has to consider the electromagnetic environment as part of the permitting process. So I wrote an article in CHIPS magazine, which is a Department of the Navy technology magazine. I have a column that I write in there, and in the I think it's the January, February, March of this year, I talk about physical obstructions, and I pose a few concepts to at least get the ball rolling. Maybe ways that we can. I know that we do have terrain models and things like that we add to some of our databases, but maybe ways that we could either register some of these obstructions that are known, etc. It's an interesting topic as we use more and more of the spectrum and share more and more of the spectrum and use higher and higher frequencies. It's something that I just think is going to become more of a problem. And at least for some of the military applications and things that we have right now, we're already seeing some of these problems with, like I say, wind farms and some other things. And because of the crisscrossing of jurisdictions or regulatory areas and stuff like that, we're not exactly sure what to do about it. Anything that would have any real binding impact. Right now, we have a pretty good relationship with our neighbors around our bases, and we try to work together. But at some point, I think it's important to try to figure out a way to make this a little bit more structured. And we're just now starting the conversation of what that would be. So that's my conversation about obstructions, my little pitch about obstructions. If anybody has we had over an hour session during my Spectrum Summit, so I can't open the floor totally to free-for-all discussion on this topic, but if anybody has a question or something, I'd be glad to entertain it.
High level, there was a, if you can hear me, high level, if there's any way to direct people to the CHIPS magazine link.
So I would accept, ironically enough, it's hosted on the Department of the Navy Chief Information Officer's website is the link to get out to it. They're the ones who sponsor it, and their website's down this week. Okay. So I'm not, but I will say this, if you simply search my name, Spectrum, CHIPS, whatever, you will find there's a science fiction writer named Chip Kid. So if you're interested in science fiction or a science fiction artist, there's that. But also if you follow me on LinkedIn, I always link to these articles and things like that. And there's a book out there that I've put all this stuff, a lot of the older articles into. And
okay, what we'll do is we'll put one of those on our on our LinkedIn. We have over 700 Spectrum managers on our closed LinkedIn, so that'll get some folks. And James Wolfson's about to ask a question. Go
ahead, James.
Yes, Mr. Kidd. The thing about obstructions, I've been in this business since 1966. I know that ages me, but that's always been an issue. there's no way. I mean, if you say you can't build anything without clearing all of it with every microwave path in the area or whatever, you'll never build another building. You know,
Right.
I remember I was dealing with Hummel or Exxon. I don't remember what it's called at the time down in Houston, and we did a lot of their frequency coordination and stuff out in the Gulf. I was with another company at that time, and kind of odd that the customer, Curtis Riddick, I'll never forget him, called me up. Hey, Jim, we've been watching this building across the street being built and getting higher and higher and higher, and they're going to top out higher than our roof, and that's where our microwave site is. We had to plan a route around it. We planned a repeater or get around it. That's the only solution.
Yeah.
And that's just one problem. I know anybody who's been in this business as long as I have will have others that that's a problem. You know?
So one way to potentially crack this nut is to get into the planning processes so that part of getting a building permit, let's say in your situation, requires notification out to some mechanism to where the spectrum environment community in the area would then know. And it doesn't necessarily give you any additional rights, but it at least gives you forewarning so that you know that it's going to happen. And there may be some ability to negotiate depending on the situation. This is probably an impossible nut to solve, but it might be something that we can at least make things better. That would be possibly the goal, is to just make things better.
Better with what you're talking about, getting a permit. That's one more thing to go through to put in a microwave path that could be a showstopper.
Yeah, that's the flip side of that too.
Yeah, one little system out there was blocking it. I've always told my customers, you don't own the rights between your sites.
Right.
The air rights are anybody's. So just be prepared.
Yep, exactly. So it's an interesting area to try to consider.
Cooperation helps. There's talking about wind farms. I was working on a project up in Illinois, and that's exactly what happened. They moved. We could plot with the software we've got what's going on, and they moved one of the windmills, and so the path would have clearance. Otherwise, it would be issues. So it's cooperation. You're right. You just got to figure it out.
So, Joe, I'm up against the bottom of the hour.
Yeah, well, thank you, Jim. I don't know if you want to preview your other idea or wait for come back for a webinar.
No, it's really, really easy on this one. So it's something that I was involved in at the very beginning, but National Science Foundation is now running with it and moving, and it's called the National Radio Dynamic Zone. Google it. It's basically a quiet zone turned inside out. It's a new concept in a physical area where people can do RF level experiments and things like that. Again, National Radio Dynamic Zone, easy acronym to remember. It's NERDS when you pronounce it. But I was involved at the conceptual stage of this, but National Science Foundation has really embraced it as part of their future. And so I fully recommend going out and Googling National Radio Dynamic Zone. And if you can participate, engage with it, support it in any way, please do. That's it.
Great. Well, thank you so much. These are big ideas. We like big ideas. And appreciate you sharing them with us. We have a lot of big brains over at NSMA who like to think about these things, and it's good to know what's coming on the horizon. And maybe we end up with a cooperation database in physical obstruction world, or we end up with a lot of participation in the NERDS zones, or who knows what else. But thank you so much for coming out. We appreciate it. This is being recorded. We look forward to getting your CHIPS article up on the LinkedIn. And
it looks like somebody actually posted a link over in the comments to one of the articles. They're listed numerically, so I'm not sure if that's my obstruction article or what, but enjoy.
All right, fantastic. Thanks so much, Thomas. We appreciate your participation. Thanks. Bye. Our next presenter will be Thomas Fagan, chair of Inarte Spectrum Management Certification Program. And Tom Fagan is all about our core science, spectrum management, and how it gets certified. So Tom will be on very shortly. Stay tuned.